1089 duplicate zeros from LeetCode. Given a fixed length array R, and it says it's fixed length, duplicate each occurrence of 0, shifting the remaining elements to the right, and note that elements beyond the length of the original array are not written, and we should do it in place, and we are not returning anything. So basically what this question is asking us to do, it says if you see a 0, add another 0, and what you need to keep in mind is, like, when we are going to return this array, it's not going to be 3 zeros added to it. It's going to be the same fixed length. So if the length is right now 8 and we are going to add 3 zeros, so we need to remove the last 3 elements from the end. So this is how it works. And if there is no 0, it's gonna just return the result. For solving this problem, we are going to use 2 pointers. One pointer is pointing at the end of the array, and another pointer is pointing at the end of the array plus the number of zeros that we have in the array. For knowing how many zeros we have in the array, we are going to use the count function to count the number of zeros. This is the example that we are going through. This is the array that is given to us. If you see, we have 1, 2, 3 zeros here. So j is going to be 7 plus 3 is going to be 10. So j is pointing to 10, and I is pointing at the end of the array, which is 7. We are going to use a while loop to iterate over this array and make these changes. For doing that, what we're going to do, we can divide this while in 3 different parts. We have 2 if conditions that we go through, which I'm going to explain to you, and then we are going to move pointer I and j one step to the left at each iteration, and we are going to do that until I is smaller than j. So let's see how we can do this, and I will go through some examples so you can better understand this solution. Let's start from I7 and J10. If j is smaller than the length of the array, we are going to put I inside the j, but j is 10 and is not smaller than the length of the array, so we don't do anything here. And then we check if I is equal to 0, and if it is equal to 0, we are going to move the j pointer 1 step to the left, and also we are going to check if again j is smaller than the length, so we can put whatever we have in the I in the j. But j is not smaller than the length, so we do nothing. Then we are going through the third step, which is going to move I pointer and j pointer 1 step to the left. And we check if I is smaller than j. Yes, it is. What we're going to do, we check if j is smaller than the length. J is not smaller than the length. Length is from 0 to 7, so we don't do anything here. Then we check if I is equal to 0 and I is not equal to 0. What we are going to do, we are going to move I and j 1 step to the left. Now we check I is smaller than j. Yes, it is. And we check if j is smaller than the length. As you see, j is smaller than the length here. Now what we need to do, we are going to put whatever we have in the I inside the j. As you see, it's here. And then we check if I is equal to 0. I is not equal to 0. We are going to move I and j 1 step to the left. Then we check again if if j is smaller than the length. Yes, it is. We are going to put whatever we have in the I inside the j. And then what we are going to do, we check if I is equal to 0, and if it is, we are going to move j 1 step to the left, and we check if j is within the range. We are going to put whatever we have inside the I in the j. We could put AI here, array I here, but I figured out, like, when we put 0 here, it's gonna be faster. So we can do that, but I think it's better to put 0 here, which makes it much faster. So what we are going to do, we are going to put 0 here, and then we are going to move I and j 1 step to the left. And then we check if I is smaller than j. It is. And then we are going to put whatever we have in the I, we are going to put it in the j. so 3 is going to be here. Then we check if I is equal to 0, it is not, and then we are going to move these two one step to the left. And we check if I is smaller than j, it is, and we are going to put whatever we have in the I inside the j, which is going to be 2. And then we check if I has 0 in it, which it doesn't, so we are going to move these two one step to the left. And we check if I is smaller than j, it is, and we check if j is within the range, it is, and then we are going to put whatever we have in the I inside the j. Then we check the second condition, we see if I is equal to 0, it is equal to 0. What we are going to do here, we are going to move j one step to the left, and we check if j is within the range, we are going to put 0 in it, right? And then we are going to move these two one step to the left, and now I is not smaller than j, and we are done. As you see, this is the right order that we get: 1 0 0 2 3 0 0 4. And this is the way that we can do that in linear time complexity, because we iterate over the array only once, and the space complexity is constant because we are not using any extra space. Thank you.